All right, let's dive into something that, well, it probably sends a shiver down the spine of anyone who's taken calculus. We're talking about related rates. You know, that part of the class where suddenly everything is moving, and it's your job to figure out just how fast.
Oh boy, there it is. The ladder. The one that's always, for some reason, sliding down a wall. I'm willing to bet this is the classic, maybe even slightly traumatic first taste of related rates for a lot of you. And if you sat there thinking, when in my life will I ever need to know how fast a ladder is sliding? Trust me, you are not alone.
And that really gets to the heart of it, doesn't it? This quote from a student on Reddit just nails that feeling of why are we doing this? It begs the question, besides these weird made-up problems, is this stuff actually useful? And the answer, which might surprise you, is a huge yes.
Okay, so here's our game plan. We're going to start with that infamous ladder problem. Then we'll see how it connects to some wild real-world stuff. Yep, even Deflategate. We'll figure out what related rates really means. I'll give you a 5-step toolkit to crush these problems, and then we'll tie it all together.
All right, let's get into it. If it's not about ladders, then where does this math actually matter? Turns out the applications are, well, they're everywhere, and in some pretty unexpected places.
First up, chemical reactions. Think about it. Reactions aren't instant. They happen over time. So if you're, say, pumping a chemical into a big tank to create something new, related rates is how you figure out the exact speed at which your new product is being made. Super important for manufacturing and, making sure experiments don't go sideways. Or how about tracking things that move? We're talking air traffic control, ships at sea, you name it. When you've got two things moving at once, say a couple of airplanes, you can use related rates to calculate with crazy precision how fast the distance between them is changing. And yeah, that's pretty crucial for making sure they don't, run into each other.
And now for my favorite, a totally unexpected one, the NFL's Deflategate scandal. Seriously. By using the ideal gas law, you might remember that from physics, related rates can show exactly how a change in a football's temperature is linked to a change in its internal pressure. It's a perfect real-world example of how two different rates of change are tied together.
So here's the cool part. All these complex applications, they're not built on some kind of secret advanced math. They're built on formulas you've known for years, like the Pythagorean theorem or how to find the area of a circle. Related rates is like the engine. It's the calculus that takes these simple static equations and makes them work in a world where everything is moving and changing. Okay, so we've seen why it matters. Now let's pull back the curtain and demystify the idea itself. Like, what are we actually doing when we solve one of these things? Look, at its core is actually super simple. You've got a bunch of things that are connected to each other, right? Like the height of the ladder on the wall and how far its base is from the wall. If you know how fast one of those things is changing, you can use their connection to figure out how fast the other one is changing. That's literally it. We're just using known rates to find unknown rates.
And here's the perfect way to picture it. Imagine you toss a pebble into a perfectly still pond. You see those ripples spreading out, right? Well, the area of that biggest circle is growing, and at the same time, its radius is growing. The speed at which the area is getting bigger is directly, well, it's related to the speed the radius is expanding. Their rates are linked. That picture right there, that's the whole concept.
All right, so we get the why and the what. Let's talk how. And forget about a confusing jumble of rules. We're going to frame this as a simple 5-step toolkit, a process you can follow for pretty much any related rates problem you'll ever see. And here it is, 5 steps. First, just identify your variables and rates. What do you know, and what are you trying to find? A sketch usually helps. Second, find an equation that connects all those pieces. Third, and this is the key calculus step, you differentiate everything with respect to time. Fourth, now you can plug in all the numbers you know. And fifth, just solve for the one thing you're looking for. Simple as that. So let's take a closer look at step 2 with a classic example. Picture two trains leaving a station at the same time. One heads east, the other heads south. The question is, how fast is the straight line distance between them growing? Well, what shape do you see? It's a right triangle. So the equation we need, it's the good old Pythagorean theorem. That's the simple, static formula that connects everything we care about. Okay, now listen up, because this is a super important pro tip. This is where everyone messes up. Do not, I repeat, do not plug in your numbers before you do the calculus step. If you substitute a value in too early, the math just treats it like a constant, and its derivative becomes 0. And poof, the whole problem breaks. So remember, differentiate first, Then plug in the numbers. Always.
Okay, we've gone from a confusing ladder problem all the way to a powerful 5-step toolkit. So let's just zoom out one last time and think about the big picture here.
Here's the real takeaway. Our world isn't static. Nothing is. Everything is constantly moving, constantly changing. And related rates, it's more than just a chapter in a textbook. It's like a special pair of glasses. It's a mathematical lens that lets us see the hidden connections that drive all that change. It shows us how a change in one tiny thing can create a ripple effect, causing a related change somewhere else.
So I'll leave you with this thought. Right now, the air pressure around you is changing. The distance between you and, the car in front of you on the highway, that's changing. Even the money in your bank account is changing, hopefully in the right direction. So next time you're just looking around, ask yourself, what unseen rates are changing my world right now, and how are they all connected?